This is about the periodic table. Sometimes I feel as if I am the beneficiary of dumb luck. This is one of those instances. From a conversation, I realized that I knew very little or possibly nothing about metals like lead, copper, and zinc, and I thought I should correct that if I could. And that led me to seek information about the periodic table. No surprise, there are a slew of books on the subject. I scrolled down a list of them, and that's when the dumb luck came in. Because the book I chose, The Disappearing Spoon by Sam Keene, turned out to be very good indeed. A doozy, that lovely combination of style and substance. The elements are grouped on the table according to their atomic number, the protons and neutrons in the nucleus, and the activity of their electrons. Not that I know what an electron is, particle, wave, charge, whatever. The best thing I could do right now would be to reread the doggone book. Then I might get some lasting value out of it. But, of course, I'm not going to do that. He covers all of the elements, naturally. I suppose that's a pun. He does so through an arresting approach based on storytelling. He knows a lot about chemistry and some about storytelling, too. A literature teacher told me that what makes a story great and the construction of the periodic table is a great story, he writes, is a climax that is surprising and inevitable. For example, he has a chapter on elements that played a significant role in our ability to wage war. Bromine and chlorine were used in gas attacks. Molybdenum and tungsten strengthened the steel used to make the huge cannons that fires shells accurately up to 10 miles. And then, of course, there are the radioactive elements, uranium and plutonium, that were used to build the bombs that destroyed 2 cities in Japan and effectively ended World War II. Keene relates similar examinations into elements that are toxic poisons, as well as the elements that are held in great value, like gold and silver. He tells about the race to create heavy new elements that exist for milliseconds. There is the cesium clock with its, 9,192,631,770 oscillations of its outer electron per second, and finding the age of matter using bubbles of helium in uranium rock. He seeds all of this with stories and chemistry. He investigates the interaction of chemistry and biology, how matter affects the mind, as well as the body. Mental phenomena seem to be bound up with material structure, wrote Bertrand Russell. He covers Louis Pasteur on chirality, chirality, Louis Pasteur on chirality, when a molecule exists in 2 forms, one right-handed and the other left. They are called enantiomers, mirror images that can't be superimposed on each other, like the human hands. They are most often caused by an asymmetrical carbon atom. The two react very differently, and that is a crucial difference when they are amino acids. Pasteur said that life has a bias towards this handedness on a deep level. Chirality was the sole well-marked line of demarcation that, at the present, can be drawn between the chemistry of dead matter and the chemistry of living matter, he wrote. That's one hell of a discovery, I think. The author wonders what really drives science forward. Theory, which frames how people view the world, or experiments, the simplest of which can destroy elegant theories. Later on that same subject, he notes the scientific world was astounded that Mendeleev, the theorist, had seen the properties of a new element more clearly than the chemist who discovered it. Chalk one up for theory. He calls Jupiter a fantasy camp for elements, where they can exist in forms never imagined on Earth. And he writes about Monte Carlo science, where the grind of experimentation is replaced by crunching numbers, calculations of probability, driven by the development of computers. It now informs chemistry, physics, astronomy, engineering, and stock market analysis. Keene looks at the work of great scientists and also says that serendipitous clumsiness and outright blunders have pushed science all through history. He made me see elements at work, like when he wrote, "As soon as the atoms in an oxygen molecule, O2, absorb heat, they disassociate and raise hell by stealing electrons from nearby atoms, a spree that makes fires burn hotter." And I think of the fires that we saw on television last night in California, and they were moving at the speed of one football field 100 yards per second over the ground. That's O2 really loving electrons. He explains research at supercool temperatures on the verge of 0 degrees Kelvin. The periodic table is never empty of surprises, he says, but with most of the easy pickings already plucked by Rankins' time, making new discoveries required drastic measures. I can't do this book justice in a short report. Every element, every scientist has their own story, and it's all quite amazing. He says that 90% of all particles in the cosmos are hydrogen, 10% are helium, and the rest, including the 6 million billion kilos of Earth, is what he calls a cosmic rounding up. And finally, surprisingly, or maybe inevitably, he calls for other versions of the periodic table, even offers $1,000 to encourage people to produce a new structure that might promote new ways of looking at the physical world. He says that Mendeleev had 30 models of the table, and by 1970 there were over 700, in addition to the standard one, created by Glenn Seaborg. For Keene, the table is not a fixed arrangement. It's a living thing.